Stan Gibilisco here with a little discussion of loop antennas, and in particular, the small loop versus the large loop. Maybe we should put those in quotes because it's all relative in terms of the wavelength. A small loop antenna is what we're showing here. The circumference is less than 1/10 of a wavelength. So, for example, if you make a small loop on the 80-meter amateur band, the circumference would be less than 8 meters. If you make one for the low frequencies, you can get away with a larger loop, but typically this is much smaller than 1/10 of a wavelength. In fact, you can actually wind several turns of wire around a powdered iron solenoidal core to get what they call a loop stick. You may also wish to tune this antenna to resonance using a variable capacitor across it like that. You can also have more than one turn of wire in the loop. You can make a multiple turn loop as long as the circumference is considerably less than 1/10 of a wavelength. A loop like this, you're looking right down along the axis, so the loop would be in the plane of your screen. The null occurs right along the axis, so right towards you and right away from you, right out of your screen and right back into it. The maximum radiation, or pardon me, the maximum reception, the most sensitivity occurs in the plane of the loop. So a station out here in the plane of the screen or way out here in the plane of the screen could be received quite well. Small loops are rarely used for transmitting because they're just not very efficient. So I've put to receiver down here. This can be an open wire line or it can be a coaxial line. But the important thing to remember about this type of antenna is that it has a very sharp null right along its axis, particularly if it's very small or if it is a loop stick antenna, in which case it is much, 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 much smaller in circumference than 1/10 of a wavelength, maybe 1,000th of a wavelength or even less. So that's the important thing to remember, because this null can be taken advantage of to get rid of strong local interfering signals, and in some cases also to get rid of offending human-made noise that may come from a specific focal point. Now the large loop antenna, and once again I will put that in quotes because a large loop antenna wouldn't be all that large at 70 centimeters, but it would be very large at 160 meters. The circumference of a large loop is typically one wavelength. It's a single turn loop with a circumference of one wavelength. Such a loop has a feed point pure resistive impedance, if it is exactly one wavelength, of about 100 ohms purely resistive impedance. So that would be a 2-to-1 standing wave ratio on 50 ohm coaxial cable. Acceptable, not a perfect state of affairs, but good enough for most purposes. The maximum radiation and response, and I say radiation as well as response because an antenna like this will work quite well for transmitting, particularly if it's a circular loop or a square loop, or in some cases maybe a hexagonal loop, something that has the maximum amount of interior area for the one wavelength that you're allowed in the circumference. The maximum radiation and response occurs along the axis, so that would be right at you and right away from you. In the plane of the loop, the radiation in response is much less. But it's not zero. It's not zero because the loop is so large that the phase of the wave here, for example, is not the same as the phase here. So you don't get cancellation, or it's not the same, or it's not opposite. You don't get cancellation like that as you would in a small loop antenna like this. That's where you get cancellation along the axis. You get a perfect null. You do not get a perfect null out anywhere in any direction from this type of an antenna. But its best response and radiation is right along the axis. And in fact, there is a slight amount of gain with respect to a dipole antenna in an antenna like this. I believe it's about 1 decibel with respect to a dipole, approximately 1 dBd gain. dBd meaning decibels with respect to a half wave dipole. So those are the small and large loop antennas. You will want to use a large loop for either transmitting or receiving. And if you can get a loop antenna, and you normally would orient such an antenna in a vertical plane, that is to say, the axis would run horizontally, so you might be able to rotate it and thereby get some directional effects. And in fact, antennas like this have been used as driven elements for more complicated arrays. That type of antenna is called a quad. Maybe someday I'll make a video about that. Stan Gibilisco, proprietor and operator of amateur radio station W1GV, saying 73 and so long for now.